Unit 4B, Lesson 3. In this lesson, we're going to talk about the quadratic formula and one other method that we can use to solve quadratic equations. We've already used factoring and then completing the square. Now we're going to learn a couple more methods to use. The quadratic formula can easily be used to solve any quadratic equation in standard form, whether that includes positives, negatives, and fractions. So if we have a quadratic equation in standard form, ax squared plus bx plus c equal to 0, all you have to do is identify your a, your b, your c values and plug them into this formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. This is the quadratic formula. This is a formula you need to know. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. First example, we want to solve the quadratic equation using the quadratic formula. We have 0 equals 3x squared plus 6x minus 11. We're already in standard form, so we need to identify our a, our b, our c value, and then plug that into the formula. Our a value is 3, our b value is 6, and the c value is negative 11. So now that we plug these values in, we have negative 6 plus or minus the square root of 6 squared minus 4ac, all divided by 2 times a. Now we just have to go through and simplify this expression on the right side. So underneath the radical, we have 6 squared, which is 36, and then we have a negative 4 times 3, which is negative 12. Negative 12 times negative 11 is a positive 132. So these two negatives make us have to add that value in the end. 36 plus 132 is 168. So we have negative 6 plus or minus the square root of 168 over 6. Now we have to simplify this radical, find factors that are perfect squares. We could break this down into the square root of 4 times the square root of 42. And the square root of 4 simplifies down to 2. And the last thing we want to do is see if we can simplify anything with the denominator. So we're looking at negative 6 and 6. Negative 6 divided by 6 is negative 1. And then 2 over 6 will simplify to 1 over 3. So our final answer is negative 1 plus or minus the square root of 42 divided by 3. One thing that might be confusing is why when I simplify 2 times radical 42 over 6, why does that simplify to radical 42 over 3? Well, you want to treat a radical just like you would a variable. So imagine we had 2x over 6. If we simplify this, I'm only simplifying the coefficients, the constants, the numbers. So 2 over 6 would simplify to 1 over 3. Well, if we're taking 1 times x, that's just going to be x, so this would simplify down to x over 3. So when you're trying to simplify a radical expression, treat that radical like you would a variable. Now to the second example, solving the quadratic equation using the quadratic formula again, we have 0 equals 7x squared plus x minus 4. So we have to identify the a, b, and c values, plug them into the equation, and simplify. So in this problem, the a value is 7, the b value 1, and the c value negative 4. Plugging those into the formula, you should get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 7 times negative 4, all divided by 2 times 7. Then if you simplify what's underneath the radical, negative 4 times 7 times negative 4 is a positive 112. You have to add that to 1 squared, which is 1, which creates 113 underneath the radical. That is not going to simplify, so our final result is going to be negative 1 plus or minus the square root of 113 divided by 14. And now to the third example, again using the quadratic formula to solve the quadratic equation. This one a little bit different because we're not in standard form yet, we're not set equal to 0. So the first thing we need to do is set this equation equal to 0. Then identify the a, b, and c values and go through the process. After subtracting 8 to the other side, you get 2x squared minus 7x minus 8 equal to 0. Now the a value is 2, the b value negative 7, and the c value negative 8. Plug those into the formula and simplify. Once you plug in those a, b, and c values, you should get x equals 7 plus or minus the square root of negative 7 squared. Now that our b value is negative and we're going to square that quantity, I recommend putting parentheses around that value, because if you plug this into a calculator and you don't use parentheses, then you're going to get negative 49 rather than positive 49. And then we have minus 4 times a, which is 2, times c, which is negative 8, all divided by 2 times our a value of 2. So simplifying that, we said 7 squared is 49, negative 4 times 2 is negative 8, negative 8 times negative 8 is positive 64. We have 49 plus 64, which is 113. We just had this radical in the previous problem. We know the square root of 113 will not simplify, so our final answer is 7 plus or minus radical 113 divided by 4. The last thing we're going to discuss in this lesson, and you're not going to find this in your notes because this is going to be pretty straightforward, is solving a quadratic equation where we don't have a middle term. So we're not going to have a b value. We don't have a term where there is just x. If we're thinking about our standard form, ax squared plus bx plus c equal to 0, we're talking about the situations where we don't have this type of middle term. So an example, if we had x squared minus 50 equal to 0. If we were going to try to solve this, all we have to do is get the constant to the other side of the equation. So we would add 50. So we would have x squared equal to 50. Now we would take the square root of each side of the equation. The square root and the squared cancel out, leaving us with x equals plus or minus radical 50. And then now the last thing we would have to do is just simplify this expression. We can break the square root of 50 down into the square root of 25 times the square root of 2, because the square root of 25 is just 5. So then our final answer would be x equals plus or minus 5 times radical 2. So in this type of situation, it's really easy to solve for those x values, get the constant to the other side, and then take the square root to both sides of the equation and simplify.